thank you for joining this talk today. I believe this is the last one. And after that, you're free to go. This is like production or to production and beyond observability for modern Spring applications. I'm Jonatan. I am part of the Spring engineering team. I usually work in a team called Spring Observability, or the Spring Observability team. I am a maintainer of Micrometer and Spring Cloud Sleuth with our colleagues Marcin and Tommy. And nowadays I also work a little bit on Spring Boot as well. I am one of the leaders of the Seattle Java user group, and you can find me on Twitter, and you can read my blog as well. So let's talk a little bit about observability, what it is and why do we need it. And you can get a lot of definitions nowadays about observability. On this talk, we are going with this, and this will be important later during this talk. So, in my opinion, observability is really how well you can understand the internals of your system, which is usually software, based on the outputs that it provides. So your software will provide you some outputs, and you can use that output to understand what is going on inside of it. Please notice that this definition has zero thing to do with the three pillars. So I don't really like that definition because it kind of suggests that that is the solution. In my opinion, it is not. The three pillars, don't get me wrong, are very, very important. Those are the signals that you will look at the most, and most of my talk will be about the three pillars. But observability doesn't stop there. Some people, by the way, started coming up like new terms, like there are 4 pillars now. And not much later after, that was like last year, there are 6 pillars as well. But to me, it doesn't really matter what number will you put in front of the pillars. Observability, you cannot really cover everything. Observability should be more. Basically all about the outputs that you can have. So why do we need it? In one word, because of complexity. Because like today's systems are like insanely complex. We are not living anymore in the era where we had like a LAMP stack with 1 or 2 servers. So figuring out what's wrong, it was like much easier because you had like 1 server or maybe 2. Now in the cloud era, we have these architectures called Death Star architectures or big ball of mud. If you know what are these, you know what I'm talking about. If you don't, you can search them or you can just look at these images. So these are Amazon, Netflix, and Twitter 10+ years ago. Every single dot on these images is an application, and the edge between them is that they are talking to each other. Nowadays, the situation is way, way, way worse than this, if you can imagine that this was 10+ years ago. Finding out what is wrong in these systems, good luck. That's pretty hard. Also, to make this worse, because of the law of big numbers, if you are on this scale, something is always broken. 100% of the time you have a production issue. And knowing about this and fixing that, it is kind of challenging. And it is not enough that these systems are very, very complicated and we have high complexity. Because of that complexity, these environments can be very, very chaotic. This means that you turn a knob here a little, and in another region, services can go down. For example, your Roomba just stopped working because somebody just like ran a script in AWS, I don't know, US East 1 S3. You can get into that situation pretty easily. Also, and this is kind of like freaking me out, and if you are also freaked out, I think you're right. We need to deal with unknown unknowns. This means that there are things in your systems, in your software, or in your applications that you know that they can be broken. Those are the known knowns. You know about them, and they can be broken. There are things that you know that you don't know. Those are the known unknowns. And there are things which you have zero idea that they exist and they can bring your production down. And somehow we need to deal with those as well. And to make things a little bit even worse, if it is possible, things can be perceived differently by different observers. This means that maybe from your perspective, everything is 100% okay. But at the very same time, maybe everything is broken in production for your users. So observability is really about like how can you handle these situations, because we are in production, and production is, because of this, quite cruel sometimes. So there are like these three big signals, or the three pillars: logging, metrics, and tracing. And let's talk about these a little bit. So logging is basically trying to answer the question, what happened in your application? And it is trying to answer this question by emitting events. And these events are almost always like human readable. You can grab them. Please don't grab them in production. Use like a log ingestion solution where you can search these logs with proper tools. Sometimes it can answer the question why something happened, but not always. For example, your log message can tell you, hey, this is exactly what happened and why. Or your stack trace, you are able to figure it out. But if your like log message and stack trace tell you that, hey, I called this other HTTP service and it gave me an HTTP 500 without an error message, that will not give you why something failed. So sometimes it can answer this question. I would say like most of the times it might not. On the other hand, there are also metrics. And metrics should give you the context of these events. It should give you the question of, hey, is it bad? Is it good? How bad or how good is this? It should give you that context by aggregating the data. And also there is distributed tracing, which should really answer the question why something happened. And it is doing it by recording these events by causal ordering, which means that if you have an event, you will know it was caused by another one, and that was triggered by another one, and so on. So you will have this parent-child relationship between events by causality. I have two examples for this. One of them is through a latency, and the other one is through an error. So let's say that you can see this in your logs that, hey, processing this very operation, it took 140 milliseconds. Is it good or bad? 140. It depends. We don't know. We have zero idea if it is good or bad, because we are lacking a context. There are people on this very conference when 140 milliseconds is amazing. But there are people, most probably on this conference, who are in the nanosecond world. So when you are optimizing a millionth of a millisecond, 140 is not just completely unacceptable, it's not even on your table. It's nowhere. So in this example, let's say that metrics can tell you that, hey, the P99.999 was exactly 140, and the maximum was 150. If this is your context, then this 140 is rather bad. It's quite bad, actually. And distributed tracing, it can tell you why is this 140. And it can tell you that, hey, this was 140 and this is slow because, for example, the database call was slow. And sometimes it can tell you that, hey, the database was slow because somebody just requested a lot of data instead of doing pagination. In this theoretical example, but I will show you these in a demo. On the other hand, error, in the error example, the logging signal can tell you that, hey, processing this operation failed, and here is your stack trace. And is it good or bad? Well, at least it's not great, because something has failed, but you don't know how bad is that. You have zero idea if everything is down in production or I just saw one single error. So that's why you can look into metrics, and you can, in this example, the metrics can say that, hey, the error rate is 0.001 errors per second. And there were only 2 errors in the last half an hour, which is not very bad. But this might not be the whole truth though, because if these 2 requests are the $1 million transactions that you were waiting for, maybe you will have a bad day. And distributed tracing, the third signal, it can tell you, for example, hey, this operation, the whole thing failed because there was a cascading error coming from the database. The database call failed, for example, because there was some invalid input error. Okay, let's talk about what you can do if you want logging with Spring. And this is pretty simple, because if you are using Spring Boot comes pre-configured with SLF4J and loopback. Sorry? Yes, but by default, it is SLF4J with loopback. So SLF4J stands for Simple Logging Facade for Java. And it is like a simple API. And basically, the concept here is you can plug logging libraries in and out. And Logback, which is the default logging library that comes with Spring Boot out of the box, it is like a native implementation of SLF4J. So that is the by default logging library. If you want to replace Logback and you want to use, for example, Log4j2, you can just like exclude one dependency, include another one, and you are good to go. So it is that simple. Let's move on to metrics with Spring. If you want to have metrics with Spring Boot, for example, Spring Boot actuator comes, or Micrometer comes with Spring Boot actuator pre-configured. So Micrometer is the most popular metrics library on the JVM, and it is kind of like SLF4J, or we like to say that it is like SLF4J but for metrics, because it has a simple API and it supports the most popular metrics backends that you can have as of today. And yeah, you can get it for free with like Spring Boot actuator, and you can get auto configuration for that. And also Spring projects are instrumenting themselves using Micrometer. And also there are a lot of third-party projects that are instrumenting themselves with Micrometer. Micronaut, Quarkus, Hibernate, Hickory CP. There is a long list of frameworks and libraries who are using Micrometer natively. So when we say that Micrometer is like SLF4J but for metrics, this is kind of like what we think about. These are all of the backends that we support as of today. And these are only the backends that are supported by the Micrometer team and which are like in the Micrometer repository. There are other backends that are like supported by the community, and they are not in the Micrometer repository. So this is not even the full picture. And did my mic just dead? It died? Okay. Nope, it's dead. Cool. I try to speak up then. You can hear me, right? Cool. So let's move on to distributed tracing with Spring. And maybe this is the most complicated because it's like not just one answer that I had so far, because there is a distinction here. If you are using Spring Boot 2, then the distributed tracing for Spring for you is Spring Cloud Sleuth. If you are using Boot 3, the distributed tracing support is given by Micrometer tracing. And there is an interesting side track here. Last year, I was on Java 1 in October. We released Micrometer tracing in November. And I was talking to my friend about it. And he asked me, like, hey, like, why are you like releasing a new tracing library? Because there is Zipkin and Brave and OpenTelemetry and Jaeger and so on. And the answer is that is because Micrometer tracing is one, not new, and it is not a tracing library. And it is not really new because Micrometer tracing is basically the successor of Sleuth. Sleuth will be discontinued. You cannot use it with Spring Boot 3 and forward. But Micrometer tracing basically was kind of like born by just getting Sleuth, copying over to the Micrometer umbrella, changing the package name, fixing a few things, renaming others, and also removing the Spring dependencies from Sleuth. This means that you can use Micrometer tracing with any Java application. It doesn't need to be a Spring app. It works with other things as well. And so that's the not new part. And the not tracing library part is basically Micrometer tracing. It's kind of like the SLF4J situation. It's an abstraction over tracing libraries. You can plug tracing libraries in and out into Micrometer tracing. Right now there are two of them that are supported. One of them is called Brave from the OpenZipkin community. And this is kind of like the default that we would like to go with, because this is like a mature project, and this was under Sleuth for years. And OpenTelemetry tracing, it is also supported. It's a CNCF project, but it is kind of like experimental for Micrometer tracing and for Sleuth as well, because OpenTelemetry is not stable yet. So there are still bits in OpenTelemetry which has this. If you look into your class path, you should find jars with the version -alpha. Now that thing it means it is not stable. Be very careful if you want to go with production with that. So that's why that is experimental, and that's why Brave is right now the default. And we have instrumentation support for like the Spring projects. They are instrumenting themselves, and they will do this instrumentation so that they will use like Micrometer tracing or Sleuth, depending which version you are using. And also there are a bunch of third-party libraries that are now supporting, or we are supporting them, or they are using like these projects to instrument themselves. And also because these tracing libraries are supporting a lot of backends, then Micrometer tracing supports a lot of backends. So you can choose which tracing backend you want to use. Okay, this is a very important part of the talk. So basically what happens here is in Micrometer 1.10, which was 2022 November, we released a new API under the Micrometer umbrella called the Observation API. And the idea behind the Observation API is that if you want to instrument your application, you need to do that multiple times, unfortunately. And you want to add logs. You maybe will start and stop timers, increment counters. Maybe you will start and stop spans if you want distributed tracing. You need to implement log correlation, context propagation, a bunch of magic. And this is also like 3 signals. You can basically have like audit logs, or like emitting events to an audit table, pushing some events to Kafka about like what happens in your system. A lot of things can happen in your app, and you need to instrument your own components and the components that you use as well multiple times, and that's a lot of boilerplate. So the Observation API is trying to abstract this out from you. You are not saying again that, hey, I want to start and stop a timer, or I'm starting and stopping a span or other things. You are just saying, I want to observe something. And what does that mean? I will talk about that later. But here, what you can do is basically you can create and start an observation. And you can, I'm just observing a thread sleep right here. You can also say, hey, if there was an exception, I want to signal that. I want to let those who will handle this know about it. And also, finally, let's stop that observation. And that's pretty much it. There are other things that you can do, like you can signal like arbitrary events. Because, for example, if you check, like this has like some kind of like duration. There is a stop and start, sorry, a start and a stop. But there are events that may be like instantaneous, or you don't care how much time did they take. You can signal those as well. Those are not on the slide, but if you go to the documentation, you will see those. This is kind of like the heart of the Observation API. Because if you start and stop an observation, instrumentation time, you don't really know what will happen with the data. But you don't even care at that point. You just want to instrument your components, and however the data will be used, it's up to the end user. It's up to those people who will like use that component and run it in production. So there are these things called, or concept called observation handler. So the observation handler is basically kind of like a listener, if you will. It will be notified when somebody starts an observation, or somebody stops an observation, or signals an error, and so on. So this means that you can write handlers like this. For example, a meter handler, it can start and stop a timer when somebody starts and stops an observation. Similarly, a tracing handler can start and stop spans. And if you want a logging handler, you can write that as well. Or if you want to go and write data into an audit table, you can just collect the data and just push it out. So the meter handler and the tracing handler is actually things that exist as of today in Micrometer. So we are giving you a class called default meter handler and another one called default tracing handler. And Spring Boot 3 will auto-configure this for you. So that means that you will get this observation registry which holds the configuration with all of the handlers. And once you start and stop an observation, you will get metrics and you will get tracing out of the box. Without doing anything, just putting these projects onto your class path. If you don't want it, let's say I just want metrics. I will just not include tracing, and that's all. Tracing will not be notified because it doesn't exist. If I just want tracing, I will not include the meter handler, so I will only get tracing. If I don't want any of these and I want to push everything out to, I don't know, to my logs, I will write just like a logging handler, and I will use that. Oh, by the way, Micrometer has one. Like, it is kind of like for troubleshooting purposes, but if you like the output, feel free to use it. There is a logging handler as well. And after you have this set up, and Spring Boot 3 will do this for you, let the fun begin, and you can basically like instrument your own application. But this is still a little bit too much of a boilerplate. Like try, catch, finally, start, error, stop, whatever. You will use this a lot of times. You will have full control over your observation, but if you happen to want this exact thing, we have this method called observe. So here, I am creating an observation, but not starting it yet. And I am also like adding key values, which are kind of like tags. There is low cardinality and high cardinality, and there is a clear distinction there because, for example, logging cannot really use high cardinality data. Tracing can use both. So based on the signals, based on the output, you can have this distinction of, hey, I only want to use like one type of the tags or key values, and not all of them. Because if you use all of them, in some cases, you can get into trouble. For example, with metrics. But the last line, that observe thing, and there are like multiple overloads of it, it is basically just getting a method reference. And it will do the very same thing I showed you 2 slides ago. Starting the observation, signaling an error, throwing that error back to you if that happened, and stopping the observation. And if there was a result, it will return it for you. So this is a very convenient way to do it. But very last line, at observed, that's the annotation. You can put it onto a method and it will do the exact same thing without doing anything else. Okay, I have a small demo application for you. And this demo consists of a couple of services. All of them are Spring Boot 3 apps. They are using Prometheus, the Micrometer Prometheus registry. They're using Micrometer tracing with Brave. And they are emitting the spans into like a Zipkin output. And there is the first service called T-service, which is called by the user, which will call 2 other services called T-leaf and voter service. They have their own databases. And we also have a thing called Eureka there, that's a service registry. So these services, when they start up, they will say, hey, Eureka, I'm here and I am up. And Eureka will register them, these services, and they will start basically monitoring them. They will ask the services, hey, are you still up? And if they are not up, they will, like Eureka will deregister them. So I will always know in my production environment how many services do I have, where are they running, and which version in which environment. This is only localhost, but this is a very serious application, you can tell, because the server is much higher than the user. Never ever trust a server which is like you can basically lift. So let's look into this application and let's make some tea. So here is our award-winning UI. You can basically just choose a tea. Let's say I want to drink a small sencha. And if I do it, then basically you can just see the recipe and the details, what I need to make this tea. But let's say I want like a large English breakfast. And, oops, there is an error here. Yep, it is not intermittent. It is happening all the time. And it seems that it is only like English breakfast that fails. That's not good. What happened? Like, do I have some friends here who broke the application for me? Let's look into this. So, as I said, we have Micrometer tracing Prometheus, and also we are emitting spans. Now, what I am going to demo today is basically through Grafana. I want to make a very clear statement in the beginning. I will demo pretty amazing things with this, but none of them are possible with only Grafana. You can do this with different things. The point here is that because of the observation API, because all of these applications are using it, with the signals emitted by Micrometer and by SLF4J as well, you can get this because conceptually the data will be there. So let's look into this. First, I have this dashboard. There is like latency and throughput. And if I make it bigger, you can see that there are some server errors, which are like ironically green. And there are successes, which is the yellow one. So you can see that I have a bunch of success operations, and I have not a lot, but it is kind of like a steady stream of issues. So it's not a one-off. It is happening. This is like 5 minutes. I can go back in time. It is happening all the time. So this is not good. What can we do? So let's look into the logs, because why not? And I am using Loki for this, which is like a log ingestion solution. You can use whatever you want. And let me try to query the logs, maybe some recent ones. So here, this is good. I have logs, but the other thing I can see is that the T service is having an error. And you can see that there was a HTTP call to the T-leaves endpoint, and it was like a 404, resource not found. Okay, so this is what is happening. But we know now that how many errors we have because of metrics. We know kind of like what happened. We don't really know why. So a very interesting thing, and the first thing I want to, or the bigger thing I want to demo is you can go and switch between these different signals and different data sets. So because Micrometer tracing, it will create a span for you, and the span is kind of like a operation that you want to observe in the distributed tracing world. That span, that can trigger like another one and another one. You will have like a kind of like a tree structured data, and all of these spans that belong together because they belong to the same operation eventually, or triggered by that, they have the same trace ID. Sorry, together, they are called a trace, and they share this trace with the trace ID. And spans also have IDs too. So Micrometer tracing will get this trace ID attached to all of your spans, and also this trace ID will be attached to all of your logs. So if I go back here and take a look again to the logs, you can see that this was an error. You can see this is the name of the application, T-service. The next one, this whole like big number, this is the trace ID, and the next one is the span ID. So I teach Loki how to extract this ID from this log message. And if I open this whole stack trace at the bottom, you can see a couple of like indexed fields that belongs to this log message, but you can also see the trace ID. So what I can do now, with this trace ID, I can copy it, go to my distributed tracing backend, and paste it. And bang, I will have, I will be able to go from logs to traces. I will have the chance to figure out why this thing happened if logging will not tell it to me. So Loki is pretty nice. I don't need to copy paste. I just press this button. And hopefully, if I zoom back and close this, then this is a trace view of the very same request that this stack trace belong to. There are a bunch of things that you can see here. So on the left, this one is basically your call stack. These are your spans. These are the basic operations that you are observing. And they are like in this tree structure. So you can like see like this span was caused by that one. And another thing that you can see is a timeline. So you can see, for example, that like this span, this at the top, which is the very, very long line on the top, this took 19 milliseconds because this other took like 7.71 and this one took 9.51. So you can get this and have some kind of like troubleshooting chance for latency and for error. And since this is an error, that's what we are going to do. So what you can see here is the T service received an HTTP GET request to this endpoint. If I open this span and look into the attributes, I can see the very same like error message that I saw in the logs. I can see that this was a not found. This was the exact URL that was called. This was a GET on this host. This was a server error and HTTP 500. So I know a bunch of details right now, but we still don't know what happened. So you can see that after T service was receiving this request, it was also emitting or like calling another HTTP like server. And it was an HTTP call, it was a GET, and it was this URL on this host. So T service is basically here. You can see that it is calling the voter service because in the next step, voter service received that request. And you can see the details of that too. I am not going to go through this because like, yeah, it's simple. But T service did not just call the voter service. T service also called the T-leaf service. And you can tell like one more thing here. If let me close these, or like just collapse them. You can tell that these two calls, these were not parallel. These were sequential calls because you can see that on the timeline. First voter, then T-leaf. And if I look into the T-leaf service, which had the issue, I can see that, yeah, T-leaf service like received the request. And it also have a database connection because T-leaf has a database. So you can see that there was a database connection to this host, to this DB called T-leaf DB, using the MySQL driver and the Hickory pool or Hickory CP. Okay. After the connection was made, it seems that T-service also had a query on this database. So you can see that there was a select query. I am sorry, this is kind of like gibberish. I am using Hibernate through like Spring Data JPA, and that's why Hibernate is writing the query. I did not write any query to do this. So you can tell that this was a select query, selecting ID, name, a bunch of other like columns from the T-leaf table, where the name equals to something. And that something, you can tell from the JDBC params, it was English breakfast. So actually with this, you can, don't do this in production again, but in non-prod environments, or if you are adventurous, you can go to the prod DB on this host, use the T-leaf DB, and just like run this query. You know the exact query that was like made by the service. And you can use that in order to troubleshoot things. So let's say what happened next. So after the query came back to us, or the results that came back to us, we processed that, and JDBC row count 0. That's a problem. That's why the whole thing is broken. This select query with the T English breakfast, it's not in the database. Which one? This one?
So, is it some of the components are masked?
Yes. By default, the parameters are not there. By default, you will only see the query, which is basically like the pivot statement. Every parameter will be a question mark. So if you're having like PII data or sensitive data, by default, it is not there. My application doesn't contain any PII or sensitive data. There is a one single like parameter in Spring Boot. You can just turn it to true, and the parameter values will be there. Also, there are ways in Boot. So with the observation API, it comes with components where you can filter these, like not just the. So one thing, you can modify everything that you can see here as you go. And the other thing, you can basically say, hey, I don't need this observation at all. I am ignoring it. Yeah. So thanks for the question. So yeah, now we know that the database is basically that there is no record for English breakfast. So let's add it. But before I would add it, you know what? Let me add it right now, because metrics needs some time to show up. So this is Postman. I'm just sending a post request. I get back 201. So the records should be created, and now the error should be gone. Fixed. Good. What I would like to show you on top of this is we went from logs to traces with the trace ID. Nothing prevents you to go back. Get the trace ID from the trace and just search for it in your log ingestion solution. And with actual like Loki and Tempo, it's again saves you the copy paste. They know each other, they are integrated. I can just click on this button, looks for this span, and this is what it will do. I wrote some like query so that, hey, I want to search for all of my applications. The organization is T-House. All of my applications has that label, and also this is the trace ID. And if I do this, I should get only those logs that are that has this trace ID. So actually, what you saw in the trace view, in some sort of form, it is also there in the logs. Not in that nice form, and sometimes it is like couple of it can have issues. It's not for the same purpose, but you should see something similar. You should see that, hey, the water service here, it basically, water service, where am I? So they are out of order as well. That's another issue you can have with logs. So you can see that the T service received a request. It made an HTTP request to water service. Here is, by the way, the database query as well. That is logged out too. The water service did this database call, also T-service called T-leaf service, and so on. You know the drill by now. Basically the same thing. You can see every single log event that was made in connection with that trace, which is a pretty nice feature if it comes to troubleshooting. Also, let's just look into our metrics. Because what we can see now is that because we fixed the issue, now the error rate goes down, which is good. So can we actually like go home? Can you see like anything else that could be wrong with this service? This is latency. We might have another issue. So as you can see here, this is like max TP99 and TP95 plotting in Grafana. And right now it seems that we had the latency around, where was it? So the max latency was somewhere between like 40 milliseconds and 100, but mostly 40 on this graph, until that point when it jumped up to 200, which is quite a big change. So what can we do with this? How can we troubleshoot this? But before I would go there, because I just forgot to show something, And also let this just generate some data so that I will give some time. I showed you how to go from logs to traces and back, but you can also go from traces to metrics. And this is possible because if you use the observation API, if you remember back, there were like these low cardinality, high cardinality tags that we attached. So metrics and traces will use the same set of low cardinality tags, which means that the key will be the same and the value will be the same all the time. There is no way that you can, okay, there are ways, but if you don't ask for trouble, then those will be always the same. So what you can do in order to go from traces to metrics, then you can just go and write a query using these attributes. All those attributes which you know that are low cardinality, you can have basically like a templated query. And you can just like substitute these values. And you can say that, hey, this is a span, which was an error, and this was HTTP 500. Show me and the get to this URI and so on, whatever dimensions you want to include. I want to see the metrics for all of the spans that are similar to this. And they are sharing the same tags. So I wrote that basically templated query, and Grafana is, or in this case like Tempo, is just giving me a button. And what you can see here is that templated query, and these keys and values, they are coming from the span. So maybe you have like 1 million spans which are sharing the same dimensions, the same values. I can go down and narrow my metrics down just to see all of those things that are similar to that. And I wrote, like this is throughput, if I can zoom back. And also there is like a query for latency. But they are pretty much the same. The key here is that you can basically like copy paste if you want, but you can also like write a script that will process a span, basically just like get out the key values from the span and substitute your metrics or like your metric query template. So that's pretty good. But let's go back to this latency section. Because the problem here is that we can see that, hey, something is wrong. We can see that something is pretty wrong because of metrics, but we don't know why. And that is kind of a tough question in terms of this problem, because we can easily go from from logs to traces and back with the trace ID. We can go from traces to metrics using common tags because the tags are the same. But how can we go back from metrics to spans? And that's a hard problem because metrics are aggregated, which means that you are kind of losing data there, which means that you have, for example, like 1 million spans, and you are, I don't know, observing latency. So 1 million spans can contribute into one single number, which was, I don't know, 200 milliseconds. How can you get from that one number, 200 milliseconds, back to the 1 million spans? That's a hard problem to tackle. And the industry just kind of figuring this out. And an answer for that, as of today, is exemplars. Exemplars are kind of metadata that you can attach to your metric values. So wherever you have that 200 milliseconds, that can have a exemplar too, which is like arbitrary key values. Most of the times, these exemplars will contain the trace ID and the span ID, because when you have this, when you calculate this metric, and you will basically measure the time, you can also sample your spans. You cannot attach all of them because you will have like 1 million spans. Your metrics backend will be very sad on that day. But you can say that every once in a while, I want to pick a span which contributed onto that data point in my metrics. So, and those are exemplars. So if I go back to this latency panel, what you can see is that there are like these three graphs. max, TP95 and TP99, but also there are like these points which are not connected. So those dots, those are exemplars. Those are sampled data. If I select one of them, I can see that, can I select one of them? Yeah, I can see that this exemplar, this belonged to an operation which took 180 milliseconds, and all of the data that that single operation had, an example of that, it has a trace ID as well. So I can get to that trace ID and again copy paste, and I can do like paste it into my distributed tracing backend, and I can check what happened or why this thing happened. And I will do a little bit more than that, because if I copy this trace ID, I am copying it like an exemplar from a data point which has high latency. And I will also ask Grafana, hey, show me a data point, different one. For example, this one. No. Show me a data point where the latency was low. And I can just split this U, paste the high latency one, search for that, and I can diff them side by side. On the left, I have the example span, which consists into a time series where the latency was low, and on the right, I have an example span, which consists into like a time series when the latency was high. So let's see what is the difference between them. The first thing is that this was like 19 milliseconds, and this was 180. That's like almost a 10x multiplier. That's not good. But why did this thing happen? So let's go one by one. And let me just not care about the timeline right now, but pull these out. So I can see that this was 19 because this was 10, around that. The T-service call was like 10 milliseconds. But here the T-service call was 160 milliseconds, not 10. So I might have a guess where this is going wrong. Also, if I check the T-service to the T-leaf service call, that is 10 milliseconds where this was slow, and it is 8 when this was fast. I don't really care about that. That's not the 180 range. Also, you can see that on the timeline. I will show that in a moment. So let's say why was this 166? So this was 166 because the database connection was 55 instead of, where is this? 5. And also the query was like also around 55 because this was 3.3. So I know now that the problem here, this was slow, the call to the T-service was slow because T-service called water service. Water service called the database, and the database is slow. Whether it is a network or like the DB itself, you can tell if the database is instrumented. In our case, it is not. I can tell you that this happened because I injected some latency into the network and the database call. I made it slow purposefully. So another thing I want to show you is because we kind of know that the database was slow, we can also check like other things in our application. Because let's say that we did not look into the trace view, and we might not know that right now it is caused by the latency. There are a bunch of times when you should do this, because like there are a lot of other causes that can happen in your application, and also there are a lot of things that you can observe because Micrometer instruments a lot of things for you. And let me just give you a gist of it. By the way, so this is not nowhere near to be complete, and this dashboard is kind of like on Grafana Hub, which is kind of like Docker Hub for dashboards. And, but I modified it, fixed a couple of things, so it's not exactly the same, but the repo is on GitHub if you want to check the applications or these dashboards. So you can see that the uptime was 1.1 hour for this app. It started at this time. Heap usage is fine. Non-heap is okay. I can see the load factor is okay, CPU usage, CPU is sleeping. If you are using a generational GC, you can use old gen and Eden and survival, like the new gen here, like the usage of it. You can see like other like non-heap areas like metaspace or code cache. Also how many classes are loaded or unloaded. That can be interesting too. Direct buffers, that is also like native memory. How many threads I have, 38, that's good. GC count and also stub the word duration. Those can be very interesting, especially if you are in the latency optimization world. This throughput and latency, this is pretty much the same I showed you on the previous dashboard, but it is with these. There is like some Tomcat stats, and this application, it doesn't have a database. So there are no Hickory CP stats, but if I select another application, like Water Service, which do have a database, I should see that there is the connection count and the connection latency. And if I go back in time, you can see here that the latency went up. That was the time I purposefully injected the latency to the database. So you can get here as well if you look into it. Also some HTTP client stats, which Water Service doesn't have any, but these services do. So you can look at that and some logback statistics. So basically we have the full circle now, because we can go from logs to traces, traces to metrics, and because you can do this like back and forth, you can also go from logs to metrics by stopping at traces and the other direction too. And the last thing I wanted to show you is these applications has much more things in them than just emitting these three signals. So I consider health check and actuator overall as observability too. So you can look into the health endpoint of these applications, and they should tell you that, hey, this application, T-service is up. It is up because the disk space indicator is up. And also it is calling like T-leaf service, which is also up. And here are all of the details of T-service, for example, the database and disk space and so on. So this is a pretty nice thing to look at. And also, this is my favorite endpoint in the actuator endpoints. This is the info endpoint. By default, info endpoint is empty, completely empty. If you just start the application, you will not get anything back if you hit endpoint. But info endpoint is basically meant for filling it up with data. So what I added here is basically some details about my build tool. I'm using Gradle 8 with these settings. You can see that this very build that I am running, it was made against this commit on this branch, and the commit was made at this time. Also, this is like the artifact name, which is T-service. I know the version, which is basically commit ID and timestamp in my case, but you can do 1.1.0, whatever. This was the time when I built the application. I can get some details about like the Java version and which like OpenJDK I'm using. This is Liberica and Java 20. Also, what operating system I'm using if you want to patch it. This can be an interesting detail by application instance. And also some runtime details, how much memory do I have, how much CPU. These can be very interesting if you are running in a Dockerized environment or like a containerized environment like Kubernetes. Some more Java details, details about the garbage collector that was picked by Java. I did not pick this. The JVM picked it for me, and some other things that you can use to troubleshoot your apps. And the last thing I wanted to show you is that because of the Eureka service registry and because I'm running Spring Boot admin, I have this nice view of all of my applications running in my laptop. How many instances do I have, which versions do I have, and also if I click on one of them, I can get a UI to this very same like Spring Boot actuator endpoint. So this is info and health, but everything is here that is available on actuator. And this is very nice if you want to discover like your services. But there is one additional thing which falls into the API discoverability space, and that is, I think that is also important for observability, is that if I call the T service, or sorry, this is tleaf service, I can get back this response. And this response is interesting because these are the normal things that you would see in a REST service, like the fields that the resource has. But what I have here additionally are links. So this is HateOS. HateOS stands for Hypertext as the engine of the application state. And that is a mouthful abbreviation. But what it does, it is basically giving you links to other resources or like how to do things with the API. So immediately I can say how to get and query this very same resource, which is like a green tea sencha. So if I click on it, I will get just one like tea leaf on this endpoint, which is pretty nice. I know how to query it, but I can also know like how to search for these. Or if I go to one, I can go back and check the collection. So I can jump between these. And the other thing I can do is interesting, because if I go down here, you can see this section. I am using a paginated API, but I only have like 4 resources. So I don't really have too many pages because the page size is 20 by default. But this also tells me how to use this paginated API. I can see that the page like property is named page and the size is size. So if I click on that and I will say that, hey, I actually want to paginate and set the size to 1, I will have a couple of pages, and immediately after I will have pages, I can see these links. So I can see what is the first page in the collection, what is the last page in the collection, what is the next one, what is the next resource, and if I follow this link and go to the next resource, I will have another link, which is what was the previous one. So I can basically go and iterate over this whole collection just by following the links to next, 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 until there is a next. And this is pretty convenient. You don't need to do the math if you want pagination. And it is like pretty convenient from the perspective of API discoverability. And I believe that kind of concludes the content I had. And the last thing I wanted to tell you is that we just released a new learning platform called Spring Academy. And it is free. There is a pro subscription. If you subscribe, you will get like free content on it, learning about like Spring projects. And also there is a discount code at the bottom. You can get like 20% discount if you sign up till April the 10th.
I have a question. So if we do the Spring Academy, I know some content is free. So if we pay for that, so what kind of content we include? We have.
If you go there, you will see. Yeah, like because the content is always changing. It's kind of like a moving target.
Yeah, like the pay content, what's the difference if you pay or not pay?
Yes, yes. So there is a difference in content. You will get more content if you subscribe. Also, last thing, I have swags, stickers, Micrometer Spring stickers, and I also have Spring socks. And if you have any questions, just go ahead.